Welcome back to the channel. Risk assessment techniques. Ensuring safety at sea isn't just about following rules. It's about proactively identifying and managing potential dangers. We have high-pressure systems, flammable liquids, heavy machinery, and the unpredictable nature of the sea itself. It's a mandatory part of the International Safety Management Code, or ISM Code, which requires every company to develop, implement, and maintain a system for identifying and assessing risks to their ships, personnel, and the environment. We're going to explore some of the most effective and commonly used techniques in the maritime industry, starting with perhaps the most fundamental, the Job Safety Analysis, or JSA. The JSA is a systematic examination of a job or task to identify potential hazards, determine the best way to prevent accidents, and implement safety control measures. It breaks down a task into sequential steps, identifies the risks associated with each step, and then defines the necessary precautions and safe work procedures. Ensures that every team member knows the hazards and the exact safety steps required. It's often carried out as part of a permit-to-work system, especially for high-risk operations like entry into enclosed spaces or hot work. Moving to a more comprehensive method, we have the Hazard Identification and Risk Assessment, commonly known as HIRA or HAZID. HAZID is usually a team-based exercise involving people from various departments, engineers, deck officers, and sometimes shore-based personnel. The team systematically reviews the design, operation, or procedures of a ship to identify all potential hazards. A hazard is anything that has the potential to cause harm. Once identified, the risk associated with that hazard is evaluated. Risk is a combination of two factors: the likelihood of the incident occurring and the severity of the consequences if it does occur. This is where we often use a risk matrix, a simple tool that plots likelihood against severity to assign a numerical or categorical risk level, such as low, medium, high, or intolerable. This helps the team prioritize which risks need immediate action. For instance, a small oil leak in the engine room might have a high likelihood but low severity, while a catastrophic fire has a low likelihood but extreme severity, both potentially resulting in a high priority risk overall. Another powerful technique is the Failure Modes and Effects Analysis, or FMEA. For each failure mode, the FMEA also assesses its severity, the occurrence rate, and the detectability. These three factors are often multiplied together to generate a risk priority number, or RPN, which dictates the need for and the priority of corrective actions. FMEA is often used during the design and construction phases of new vessels and for statutory surveys to ensure critical systems meet the highest reliability standards. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share,